Hello, my name is Shadun Vijayan. My card matrix number is CN190254. Today I'm going to present about my PSM. My title is The Design and Development of Aquaponic Piping System for Urban Farming. And my supervisor for this PSM is Professor Abdul Muttalib bin Leman. The introduction of my project is due to the rapid urbanization, land resources for agriculture have been decreasing. So the fast expansion of human population has led to an increased pressure place of the world's supply. The conventional technique for cultivating plants need a substantial amount of space as well as time and labor. Aquaponics could be a good solution for food security and sustainability. The piping system is playing a major role in developing the aquaponic system. The problem statements are: first, the aquaponic is not being developed because it is difficult to fix. There is no standard design as proven is to be simple to operate. Then second is aquaponic is tough to maintain because it demands frequent feeding, water addition, pH testing, and pump and piping cleaning. And then here, many people have trouble putting these components together since they all need to be drilled and cut to exact dimension and lengths in order for the piping to work properly. And the last one is the fish and plants will die if water never flows properly on the pipes. So the objective for my projects are: first, to design and make comparisons in the selection of aquaponic system. The second is to develop a nutrient film technique based aquaponic system for urban farming that can growing up the aquatic species and soilless plants in a single recirculating system. And the third one is to test the aquaponic system in terms of water, energy, and nutrient. The scope of studies of my projects are uh, to design the piping system using PVC pipes. And the second one is 0.75 horsepower of some pumps is prepared for this project. And then third one is the hydroponics beds are lettuce, spinach, and basil. And then aquaculture unit are tilapia and catfish. And then 75 gallon polyethylene and 150 gallon are used as a fish tank, and 25-liter bucket is used as a biofilter tank. And then sketching is used in SolidWorks software. And then run the test space at least 8 to 10 days to avoid from the technical problems. Now from the literature review, my first subtopic is hydroponic unit. There are three types of hydroponic unit. First is nutrient film technique, second one is rough system, and the third one is blood and drain system. In my project, I used nutrient film technique as a hydroponic bed. The material used to fabricate the hydroponic bed is PVC pipes, and then I used 3 inch of PVC pipe as a hydroponic bed. In the research, the plants may range from 4 to 9 inches in width and 1.4 to 4 inches deep. The plant seeds are placed in 4 cm in a diameter of net cups and stick it into a hole that has been drilled in the surface of a PVC pipe. The number of plants can grow uh, in 76 units in the hydroponic bed system. Okay, the second subtopic is aquaculture unit. In my project, I used a polyethylene tank. Then, in the research, the fish tank should be covered as a prevent fish from leaping out. And then, the tank made a tough inert plastic or made of fiberglass due to the longevity of materials. In the polyethylene tank, the work very well as fish unit is aquaponic system by previous researchers. The fourth subtopic is the biofilter. I used solid filter and mechanical filter from 25 liter of plastic buckets in my project. So the biofilter should be installed so that identifying bacteria may colonize and convert fish waste toxins ammonia into nitrate, which plant can easily assimilate. So the third one is the biofilter was content of K1 biofilter, and the bottom of tank is made up of a layer seashells which acts a colonization ground for bacteria. And then the mechanical filter, the gravel on the bottom of the tank collects and blocks the solid waste. And now it's plant selection. The crop selection is very important for the aquaponic system because it needs to match fish and plants with similar pH and temperature requirements. So in my project I have selected the lettuce, spinach and basil, and then the lettuce is a cold season crop needing growing temperature ranging from 7 to 24 degrees Celsius, and the average of 18 degrees Celsius per second, and pH value requirement between 6 to 6.2. The spinach pH value requirement is around to 6 to 7, while the temperature range from 45 degrees to 75 degrees, and then pH value of the basil requirement between 5.5 to 6.5, and the temperature is 65 to 85 degrees Celsius. Now it's fish selection. So the warm and cold water species that are best suited to required aquaculture system. So the most of previous researchers are selected tilapia, catfish and bluegill in the aquaponic system, but I have choose tilapia and catfish in my aquaponic system project. So the tilapia hydel growth from 37 to 86 degrees Celsius for their growth, and then the hydel temperature range for catfish is between 65 to 90 degrees Celsius, while the hydel pH value range is between 7 to 8. Okay, this is very important for the aquaponic system because without plumbing and fittings, we cannot make the aquaponic system. So the PVC and CPVC and HDP pipe are commonly used in the aquaponic system. So PVC pipe is majority used by the previous researchers in the nutrient film technique. So in the aquaponic system, the fittings are very important because it will be prevent the water leaking from the PVC pipes. So now the water quality. So first one is dissolved oxygen. So in the most of aquaponic system should have dissolved oxygen concentration of at least 5 ppm. And the second one is water temperature. So the water temperature in the system will influence the fish, and then the water temperature is important for optimum growth and to avoid the fish dysentery. And then the pH value of the water utilized in aquaponics system is an important indication of its quality. When the pH falls below 6 and higher 7.5, nitrifying bacteria stop generating the nitrogen. And then the fourth one is the parameters. There are four types of layout. First one is extraction. The extraction between fish tank to biofilter, and then the second layout is filtration. Filtration is between biofilter to hydroponic tank, and then third layout is utilizations. This happens in the fish tank with the sump pump, and then the fourth one is recirculation of the aquaponic system. This is the flowchart for my PSM. First start, and then we have to find the research about the aquaponic system, and then the third one is construct the technical drawing for project designs, and then the project design selections, and then measure the parts and identify the parts materials, and then we have to find out the cost of developing of the aquaponics project, then finalize the design. After finalize the design, fabricate the aquaponic piping system, and then the last is testing project, and then it's end. Now it's about the morphology of design selection. Okay, this is my first concept. So the component is under 50 and 75 gallon polyethylene tank, and then 25-liter bucket used as a solid filter and mechanical filter. And then I plan to use in concept 1 0.75 sump pump, and then PVC pipe inch 2, PVC pipe inch 3, 90 elbow inch 2, 3 inch 1.5, and then PVC pipe 1 inch, and then bottless rack. In the concept 2, not so much of different, using 100 gallon of polyethylene tank, 150 liter drum tank as the biofilter, and then use 1 horsepower centrifugal pump and PVC pipe 2 and PVC pipe 3 as hydroponic bed unit, and then 90 elbow inch 2. The third design of concept 3, 100 gallon polyethylene tank, 150 liter drum tank, 1 horsepower centrifugal pump using PVC pipe inch 3 and 90 elbow inch 3. As the comparison for the three designs, so the manpower for design 1, design 2 and then design 3 are 1 manpower. For the machine is for in design 1 using 0.75 horsepower sump pump, design 2 1 horsepower centrifugal pump, design 3 is 1 horsepower centrifugal pump. The materials are here, and which I mentioned just now in the previous slide, and the money for design 1 is 854 ringgit, in design 2 1756 ringgit 50 cent, and in design 3 is 1777 ringgit. Okay, concept 1 is my finalized design for my project. I and my supervisor discussed and finalized this design because this design is well organized and in the well positions. This is my project budget. First, recycle item costing, and then its total is 687 ringgit, and then the purchase item costing, the total is 167, then the total costing is 854 ringgit. Now the testing and fabricating the aquaponic piping system. So first we have to measure the pipes in the correct length and the dimension, and then we need to start cutting process as follow the measurements, and then after that we need to do the drilling process for the hydroponic bed. Once finished, we have to do the shape and framing for the aquaponic system, and then we need to do the installation process to run the aquaponic system. Okay, this is my fabrications result. This the first picture is front view, the second picture is side view. I did this project in my supervisor's house, so this is my design as we seen in the concept 1. This is my testing result. The first picture shown the water inside the hydroponic bed. It functions very well. We do the test for 10 days, so there's no leaks, and then the water cycle to finish completely the system is 60 to 70 seconds. The second picture is the growth of fish after 2 weeks. So the fish were managed to grow by 0.75 to 0.85 inches. So these fish were fed twice in a day and managed to keep growing. In order to guarantee that the fish in the tank are in excellent health, it is important to check the water quality in the tank on regular basis. The third picture is the plants. So the growth of plants also taken after 2 weeks. They had three types of plants are lettuce, spinach, and basil. So these plants were grown to 7.87 to 7.96 inches. So these plants are grown without the any chemicals, fertilizers, and then instead rely on nutrients that have been biofiltered from the waste produced by the fish. So the water quality testing are taken. There are three types of testing are taken. The first one is ammonia, the second one is nitrate, and the third one is pH value. So the water quality data for fish tank 1 was recorded every 3 days for the total 3 weeks. The result of the first and second testing showed the reading of ammonia was 0.1 ppm and the nitrate was 0.05 ppm. It was because the size of the fish in tank 1 was small and prevented them from consuming pellets at a high rate, which led to low ammonia and nitrate concentration at the beginning of the test. As a result, the amount of waste produced from the fish remains negligible, which insufficient. The nutrients are nevertheless sufficient for the distribution to the plant units. The levels of ammonium nitrate both rose in the third test, with the ammonia reading reaching 0.2 ppm and the nitrate reading reaching 0.1 ppm. On the fourth day, the ammonia and nitrate levels still remained same, while in the fifth day both increased. Ammonia was 0.4 ppm and the nitrate level was 0.33 ppm. In the sixth day, the ammonia level was 0.2 and nitrate level were 0.1 ppm, which seemed decreases due to the filtration in aquaponic system contains bacteria that consume ammonia and nitrate. Throughout the period of the project, the pH level of the water progressively became more neutral, moving from an acidic value at the beginning of the first and second test, which was a value of 6, to a neutral value on the third and subsequent test, which was a value of 7. So now for the fish tank 2. The fish tank 2 also same. uh, the tests are taken every 3 weeks for every 3 days. So the result for the first to third testing showed the reading of ammonia was 0.1 ppm and nitrate was 0.05 ppm. So it was because the size of the fish in tank 2 also small and prevented them from consuming pellets at high rate, which led the ammonia and nitrate concentration at the beginning of the test. The amount of waste produced from the fish remains low, therefore the nutrients and other sufficient for the distribution of plant units. The levels of ammonia reading reaching 0.2 ppm and the nitrate reaching 0.1 ppm. On the fourth day, the ammonia and nitrate levels still remained same, while in the fifth day both were increases. The ammonia was 0.3 ppm and the nitrate level were 0.2 ppm. So in the sixth day, the ammonia level was 0.2 ppm and the nitrate level was 0.1 ppm, which seems decreases due to an aquaponic system. The filtering process utilizes bacteria that are able to break down the ammonia and nitrate. So throughout the duration of the project, the pH level also as same as in fish tank 1. um, Fish tank gradually become more neutral, shifting from an acidic value at the beginning of the first and second test, which was a value of 6, to a neutral value on the third and subsequent test, which was a value of 7. So in other words, we can say the water went from having an acidic value of 6 to having neutral value of 7 over the course of the project. Okay, this is my conclusion. So all my objectives are achieved and the operation of the system was well controlled through the entire fabrication process, and then the biofilter are able to ensure the plant fertility and sustainability of aquaponics system. Thank you.